Hi everyone. So today we are taking the real plunge into measures of spread properly, which means that we're starting to talk about the range. Also the interquartile range, which you would have come across at GCSE, but adding percentile ranges into that. So the interquartile range would tell you where you're at with the middle half of your data, sort of cutting off the top quarter and the bottom quarter. But it may well be that you only want to cut off the top and bottom 10%, so you would have the 10th to 90th percentile, as we're going to look at in our first example, where we start looking not at trivial little biscuits like maybe a bourbon, which is what I'm going with today. Not my favourite, I must say. A lot of people seem to rate them, but I just think cheap, chalky kind of cocoa powdery things. Anyway, we're going to be looking at the largest creatures to walk our work planet today, which are of course African elephants. So let's crack on with that. Right, so here's our data about the elephants. It says, first of all, an estimate for the range. So have a little look at it. The heaviest possible elephant is what we have to go with. So it could be as much as 6.5. I know it says less than, but it could be 6.49 recurring, couldn't it? And it's going to be more than 4, but it could be as little as 4. So 6.5 take 4 is 2.5 meters. That's all that is. That's a pretty basic question. But the interquartile range now, we're going to have to use what we were doing last time, which was interpolation. I can't remember if I stressed that word at all because it's a new one. So it's called interpolation, and it's where you use a logic to find where that quarter point for and the 3/4 points in here are going to be. So we want 1/4 of 120 is 30. So we want the 30th result in here. And we've got 13 there, so, and 13 plus 23 makes 36 at that point, so it's definitely in here somewhere. So 30 take 13 is 17. So we want the 17th out of 23 to find the lower quartile, but we also want the upper quartile because the interquartile range is going to be the upper quartile take the lower quartile. So if I start thinking about that as well, 3/4 of 120 will be the 90th. Add on another 31 gets me to 67. Add on another 34 to that would get me to 101, and then we do indeed have 120 at that point. So the 90th is somewhere in this zone here. So 90 take 67 would be 23. So we want the 23rd thing there. So I'm going to go for the upper quartile first, and I'm going to do it all in one go, so I can just smack it into my calculator in one go. So I want the 23rd out of the 34 that are in that zone. And how wide is that zone? It goes from 5.5 to 6.0 exactly. So that is a gap of 0.5. And once I've got that, I'm going to need to add it to the beginning of the class width that I've got here, which is 5.5. I don't need to put brackets around that, but you can if you like, but BidMass takes care of that in the calculator. So that is Q3, or the upper quartile. And I'm going to take away Q1, which is going to be the 17th one in here, isn't it? So we're looking at 17 out of 23 multiplied by the same class width of 0.5, but the start point here is 4.5. And if I put all of that into the calculator, it should look something like press equals, and I get 0.9 so 2, 3 significant figures, that would be 0.969. And what are our units? That's ton. It's tons, isn't it? So they're varying by almost a ton from the lowest quarter to the highest quarter. Right, and then what's the next thing? The 10th to the 90th percentile range. Well, it's very, very similar. 10% will be 0.1 times 120. That's your 12th elephant. Your 90% is going to be 0.9 times 120. That'll be your 108th elephant. So the 12th is almost at the end of that. We're going to do the same thing again. We're going to do the 90th percentile first and then take away the 12th percentile, and that should look something like this, and whack that in the calculator and you should get 1.722, so that's 1.72 tons. So varying a fair bit more, but because you've got a whole 80% in there instead of just 50%, haven't you, in the middle? Right. So that's our example. We're going to work through 3 more now, I think, and see how we get on with that. Okay, pause the video, give it a go before you watch me go through it. So we're looking for 34% to 66% range. So we're going to take the biggest from the smallest. So if we start with the 66%, 0.66 times, well, how many workers have we got? 3 add 24 is 27, add 28 is 55, add another 15 is 70. So if we multiply that by 70, we get 46.2. So that's how far through we want that. We want the 46.2 best paid worker, or worst paid worker. And so where's that going to come? That's going to come in here somewhere, isn't it? Because there's your 27, there's your 55. So take 27 away from that, and we get 19.2 into this zone. So I'm going to say, right, I've got 19.2 out of the 28 that are there. I'm going to need to multiply that by the class width, because how spread out they are, which is £100 worth from 1100 to 1200. And then I'm going to need to have the starting point of that, which is 1100. I'm going to need to add that value to 1100. That will be my 66th percentile. That's interpolated. Now I'm going to take away the 34%. So 0.34 times 70 is 23.8. Oh, can't write on that. Anyway, take away from that, we know that's in there, take away the 3 that aren't in there, and we get 20.8. So we want 20.8 out of the 24 that are in there. Again, the width is 100, but our starting point is 1000. And then we whack all of that into the calculator, which should give you 81.904, and with money you always round to the nearest penny, so that's £81.90. Now we do have one more question coming for this. Estimate the number of data values that fall within this range. Alright, pause the video and give this one a think. So, this is all about what proportion. You don't need to worry about what the data values are. The range is from 34% to 66%. So, if you think about it, 66 take 34 is 32%. So we're talking about the middle 32%. So what is 32% of, well, how many have we got? 70. Whack that in. 0.32 times 70 is 22.4. And this is where the estimate comes in, estimating the number of data values coming in. It's not going to be exactly 22.4. We can only have a number of data values, so our estimate will be 22 because it rounds to your nearest number. Right, we're going to do 2 more questions for you to practice on. So pause the video and give this one a go. Right, so our train's going from Lancaster to Preston. The times are to the nearest minute, which means we've got to be super careful because our actual points are 18.5, 16.5, stuff like that, which is actually 30 seconds as well, which can be a bit confusing, can't it? We need to calculate the 95 to 95 percentile interpercentile range. So we're looking at 0.05 of however many journeys we've got altogether. We've got 15, 50, 60, which is 3. So that's your 5 percentile, and your 95 percentile is going to be at, well, it's 19 fives, isn't it? So 3 times 19 being 57 will be where your 95th percentile is. So we need to interpolate that. Next thing I do to make sure I don't make a mistake, I know I've got 5 there, plus the 10 makes 15 to there, plus the 35 gets me to 50 there. So if I want 57, 57 take 50 is 7, so I'm going to, for the 95th percentile, need 7 out of those 10 there. And I'm going to be multiplying that by, well, if it's to the nearest half, that's got to be to 20.5. And this even goes up as far as 22.5, which means the class width is actually 2 and not 1 minute. And then we're going to need to be adding that to 20.5, and we can worry about it in terms of seconds afterwards. Then, taking that away from that will be the Q1, or the lower, no, quartile, sorry, 5 percentile. So we're looking at 3/5 of the way through. That starting point be 14.5. So again, it's a 2 width thing, and we're starting at 14.5. Put all of that into the calculator, and you should get 6.2 minutes. Now you can actually just leave it at 6.2 minutes, but I don't really like doing that. I would rather say 0.2 minutes. Well, how many seconds is that? Well, 60 seconds divided by 10 is 6 seconds for 0.1, isn't it? So it would be 6 minutes 12 seconds. But either one of them is actually okay. And then estimate the number of data values within this range. Well, how many have we got? We've actually got 90. We're losing 5% there. We're losing 5% at the top. So we've got 90% in the range, and 90% of, how many have we got of 60 is 54, and that's exact, so that's what our estimate will be. Okay, final question. Pause the video, give this one a go. Well, the first thing to do to find the median is you've got to put them in order, so that should give you something looking like this. Oh, now don't worry about the fact that it says from the large data set. Sometimes that's relevant, sometimes it's not. Generally, the only things that are relevant about it are knowing about where some of the data would have been rounded, and where some of it wasn't applicable, and all that sort of thing, and where you are in the world and things like that. But if there's no question about that, then you don't need to worry. Right, so we've got 10 days, 1, 2, 3, 4, 5, so it's halfway between 10.9 and 12.1. 10.9 plus 12.1 divided by 2, giving you 11.5 degrees. And then the interquartile range. Now for this we need to remember what we said last week about our rules. We've got 10 data points, so if you divide that by 4, a quarter of it is 2.25. That means you round up to the third data point. So that is Q1, or the lower quartile. Then for the third one, 3/4 of 10 is 7.75. So again, you round up to the 8th value, which is that one there. So the IQR, or interquartile range, is going to be 12.7, take 10.3, which is 2.4 degrees C. Right, moving on. Median daily mean temperature for Liming during the first 10 days was 9.9, and the interquartile range was 3.9. Compare the data for May with the data for June. So we've got our information on June. There's 2 marks. Whenever you're asked to compare, you need to compare 2 things. One is an average, the other is a range. So all we've got to say is that on average it was cooler in May, or you could say warmer in June. And what about the interquartile range is 3.9, but the range is more, isn't it? So in that case, but it was also less consistent. In May, the data was more spread out. Okay, moving on to part C. The 10% to 90% interpercentile range for the daily mean temperature during July was 5.4%. Estimate the number of 5.4 degrees, sorry. Estimate the number of days in July 87 on which the daily mean temperature fell within this range. Right, so you've got minus 10% from the top, 10% from the top, you've got 80% of your 31 days in July, so make sure you know how many days there are in each of the months, because that is important. Do 0.8 times 31, you get 24.8 days, so that means we're going to need to estimate 25 then to the nearest whole number, the number of days you'd expect to fall in that range. Some people always round down on that. The important thing is show you're working. Okay folks, that's all for this week. Next week we will move on a little further.